I'm Nolani and this is Mia, and we're seniors from Park High School in Livingston, Montana, and we did a project on slinkies in microgravity and we called it Slinky Madness.
We watched Don Pettit's videos from the ISS and we were really interested in them, and the one that we took the most interest in was called Spring Theory, where he tied different weights onto the spring and then watched how the frequencies changed. And after watching that video, we were just really curious as to how other springs reacted in microgravity, which is how we came up with our slinky idea.
So this is our project, and in comparison to Don Pettit's, where it was more sideways and then you noticed the motion moving back and forth, ignore that part, we did it where it was vertically. And so we did where we split the slinky in half so that one was resting on top and then one was suspended, and then we moved it so where we put it in this contraption pretty much. And this was the Velcro, this is where we put our project, and here's the camera and here are the lights to get better lighting. And we held it up, and then we had the camera running and we dropped it down into pretty much a big box of packing peanuts that would have a soft landing. And then we would look at the video and slow it down to be in slow motion. So that state of free fall created a state of microgravity.
As we found out, the bottom part did compress up as expected and the top part did expand, which was what we thought, but we'd also thought that they were going to go at the same rate and leave at the same time, but that didn't happen as we had expected. The top part actually took off faster than the bottom did.
So it kind of went like this, where the top it moved a lot faster and farther, but then after just a few minutes or seconds they started acting almost reflecting each other.
And then also we thought maybe that the top took off sooner because of a flex in the cardboard when it was suddenly subject to microgravity. But when watching the videos and slowing the speed down so it was easier to see, we couldn't detect any change in the cardboard at all, which might just be due to the technology that we used. But as far as we could tell, there's no flex to start the spring off quicker. That's just how it reacts in microgravity.
So as far as the behavior of slinkies when they're in microgravity, we determined that once it's in microgravity and gravity doesn't have as much of an effect on it, and it's not compressing this down so much or suspending this so much, then it tends to move to a more relaxed state, which is about there. It's not really extended or it's not really compressed like that, but it tends to move in that spot. But of course, from the momentum, it's going to be moving more. So that's what we determined from our project, although there might have been some variables included in it. So again, we are Nolani and Mia from Park High School. We're seniors, and this was our project in microgravity of Slinky Madness.